Hello world, and welcome to my YouTube channel and my very first YouTube video. Today we're going to try to solve probably the most common LeetCode problem in existence to some, and it's relatively straightforward. You're going to get a list of numbers, and we want to basically find two numbers in that list that equal a target number, and we want to return the indexes of those two numbers that add up to our target number. And one nice thing is that we know that inside our input, there will always be exactly one solution, and we can't use the same input number or element in our list twice. So let's walk through a simple example. So if we have a list of 2, 7, 11, 15, and we're looking for the number 9, if we look at our list and we see that, okay, numbers 2 plus 7 equal 9. And so we're going to return the indexes 0 and 1 because they map to 2 and 7. Similarly, if we're given a list of numbers 3, 2, and 4, and we're looking for target number 6, we notice that nothing added to 3 in our array equals 6, but if we add 2 plus 4, we get 6, so we return the indexes 1 and 2 because they map to 2 and 4. Finally, in the last case, there's only one solution because we know there's always a solution. There's only two numbers, so the result is 0 and 1. But also critically, it tells us that inside of our input list of numbers, that numbers can be repeated. And that's going to be useful to know down the road in case there are matches like this, which in this case 3 plus 3 does equal 6. So before we make a super fast, great solution, I always like to write a brute force simple solution first to get something working, and then we can make it fast later. So if we had to brute force this problem, what we could do is basically say, grab a number from this list, compare it to every other number in the list, and basically ask ourselves if our current number plus the other number equals target, then we're done, right? And if we checked every possible combination, there's nothing, then we got a bad input. Okay, so that seems straightforward enough. Let's try coding it out. So we can get a number by just iterating through the list, right? So int I equals 0, while I is less than nums dot length I plus plus. Right. Now we can get every other number in the list by just making another for loop. So we're going to do int j equals I plus 1 because we don't want to compare a number to itself, right? And we say, well, j is less than nums dot length j plus plus. And oh, I have an extra space here. Better fix that. Finally, we can do our check and see if we are done or not. We can say, oh, if the number at I plus the number at j is equal to target, then we're done. And we should just return the indexes I and j. We can do that by using a simple array initializer and say return a new integer array with the with the values I and j, right? And if we loop through this, all the numbers, and we get nothing, then we should probably blow up and tell Java they gave us a bad number. So we can just say throw new illegal argument exception, right? Because that's not good. So let's run it and see what happens. Great, our solution worked. But we can tell that it's obviously slow. It only beats, what, a third of all the number solutions submitted, right? So clearly there's room for improvement. If this was a real interview, an interviewer would probably ask us, how could we make this faster? And that's what we can try to look at next. So when looking at like an existing brute force solution, we can look at it and ask ourselves, how do we reduce the amount of work this is doing? And if we look at this algorithm, right, we have to go through all the numbers and then we have to find another number that adds up to target. And our finding process is actually kind of labor intensive. We search through every other number one at a time. If we could look up the other numbers faster, then we could reduce the time our algorithm takes to find a solution. And if we think about what data structure has really fast lookup times, then we need to use a hash map. So how could a hash map help us here? Well, we could make a map of numbers to search for, and then if we find what we're looking for, we can return the result. What do I mean by that? Now's the time to maybe start defining things. We can say that if we have a current number, let's say 2, and we're having a target number of, let's say, 9, then we can say that the other number that adds up to 9 is 7, and we can call that other number a complement, right? So we can say the complement is equal to 7 because 2 plus 7 equals 9. Similarly, if let's say our current number is 3 and we're looking for something like 6, then we can say the complement of 3 that would give us 6 would be 3 again, right? And the idea is, let's say we had a map where key is equal to the complement and the value is set to the index of the number that needs that complement. So what do I mean by that? We could say that in our array, in our map, that we have something like the complement 7 in this example, right, would map to index 2, right, and so on. And the idea is basically that we could search this part of the code way faster and reduce our time. But that's kind of hard to explain, so maybe let's code it out and show you guys what we're doing, right? So let's maybe delete our old brute force solution and make something fresh. We'll make a map of complements, right? And then go through each number in the list, right? And we'll ask ourselves, is our current number a complement to something we have seen before? If yes, then we have a solution. If not, then we can record the complement of our current number and add it to our map, right? And similarly, eventually we'll find a solution, except now that we have a really fast lookup process, it should happen a lot faster. So let's turn all these comments into code. So we can define a map of integer, integer, and we'll say this is our complements map. And we'll say this is a new hash map. I'm going to go through each number in the list. Int I equals 0, while I is less than nums.length I plus plus. Then we'll get a current number. Just to make it similar to the last solution, we'll say it's like integer j, right? And we'll say that, okay, let's check our complements map dot get nums I, right? So if j is not equal to null, which means we have a hit, then we have a solution. So let's return that solution, right? We'll return a new integer array with the indexes I and j again, like we did last time in our brute force solution. And if not, let's just add whatever we have to our map and move forward. So we'll call the complement equal to target minus nums I, and we'll add it to our map. So complements map dot put complement, and then the current index we have. And with that, we should find a solution eventually. And if somehow we get a bad input, well, we can still throw our exception here and say, well, you gave us a bad input, so there is no real solution. Let's try submitting this and see what we get. And clearly I have a bug in my code. I cannot compare an integer to a null in Java. Well, clearly I do not know how to code, and I will just get rid of the extra number and just call the function twice. Now is it happy? And it is. Well, thanks Java. Anyways, it seems that now our solution is way faster. If we look at it now, we can see that, okay, because we have to loop through every number and the lookup of seeing if there's a hit is only O of 1, we have a O of n solution, which is way better than our last solution that was O of n squared. Well, that's it for today. I hope you learned something.